My dear students, today I would like to discuss merits and demerits of the Bentham and Hooker's classification. Here you are observing there is something interesting in the classification, that is Bentham and Hooker's, which is a very specific and it is a very great natural type of classification for the botanists. Classification, you know very well all that it is important fundamental aspect of the taxonomy. In taxonomy, there are three important components. One is identification, second one is nomenclature, and the third one is classification. Classification means it is a lawful arrangement. That is, the term taxonomy itself indicates that it is a lawful arrangement. So, after identifying the plants and naming the plants, we have to classify them according to the some laws. So, what are those laws? They are very particular for the according to the code which is called as the International Code of the Botanical Nomenclature. There are various types of the classifications we know. The three important classifications we all know is, one is a artificial system of the classification when taxonomy was initially started, later proceeded to the natural systems of classification, and finally the evolutionary type of classification which is called as the phylogenetic system of classification. But recently there is one more type of the classification which is called as the modern classification or synthetic classifications. But today we are only discussing about the fundamentals of Bentham and Hooker's classification, merits and demerits. Here you are finding the two important scientists. One is on the left side, which is called as the George Bentham from 1800 to 1884, who contributed his works to the taxonomy, and the other scientist on the right corner, that is Joseph Dalton Hooker from 1807 to 1911. These two are the two English systematists. They worked in the Kew Royal Botanical Garden and published their monumental work in a book called Genera Plantarum. This Genera Plantarum has published in 3 volumes from 1862 to 1883. This is nothing but a natural system of the classification. See, the George Bentham and J.D. Hooker, they published their classification after the publication of the species, that is natural selection, published by the Darwin. So, they must follow the Darwinian principle, but George Bentham never believed in the Darwinian principle. Of course, Hooker favored the Charles Darwin principles, but Bentham opposed and he followed in his own manner. They described at that time when there are no transportation and there is no communication facility, it is highly difficult to explore the plant data, but they did a very elaborative work at that time in 19th century describing about 97,205 species and they distributed all these plants into 202 orders. It is not such a simple thing for the two persons to work on the plants and to give that elaborated data. That is why it is the first and even the last great natural system of classification, and it is also very easy to follow for the botanists. Next, if you observe the next that is plant kingdom, you know very well that plant kingdom is divided into two divisions, that is cryptogamy and phanerogamy. Cryptogamy deals with the non-flowering plants, that is Thalamiflorae, Bryophyta and Pteridophyta. Today we are not dealing with the classification. Coming to the phanerogams, that is flowering plants. Bentham and Hooker taken these plants, phanerogams, and classified into 3 classes, that is Dicotyledons and Gymnospermae and Monocotyledons. These dicotyledons are further classified into 3 subclasses, that is Polypetalae, Gamopetalae and Monochlamydeae, which are further divided into series. Polypetalae divided into 3 series, that is Thalamiflorae, Disciflorae, Calciflorae, and Gamopetalae divided into 3 series again, that is Inferae, Heteromerae and Bicarpellatae. The Monochlamydeae again divided into Curvembryeae, Multivovulatae aquatica, Multivovulatae terrestris, Daphnails, Ecchlamydospore, Unisexuals and Ordinus Anomalae, that is the 7 series. In Monocotyledons there are 6 series starting with Microspermae, Epigynae, Coronariae, Calcinae, Nudiflorae, Apocarpae and Glumaceae. This is the classification in gist given by the Bentham and Hooker. So, when you observed in the last slide the Dicotyledonnae, there are 3 subclasses and 3 series. There are orders, you are observing that under Thalamiflorae there are 6 orders and 34 families, but coming to the Monochlamydeae, the Curvembryeae is directly divided into the 6 families. Even in the Monocotyledons also, the series is dividing into families. There does not exist no cohorts. So, there are these 2 great systematists did a very well elaborated work. At the same time, they forgot about the important contribution done by the several scientists at that time. Looking at the merits of the classification, this is the important classification, which is this is quite accurate and reliable. The description of the plants is also very easy to follow as a key for the identification of the plants anywhere, anytime and anywhere in the field. That is why several herbaria including Royal Botanical Herbarium and several other herbaria all over the world are following in the several countries including India. Though this system is natural, most of the aspects of the classification lie towards the modern concepts of the evolution. Though they know the concepts of the evolution, they did not follow the concepts of the evolution, but in the system we will observe that the classification is lying towards the modern concepts of the evolution. For example, in the Thalamiflorae, it has started with the ranales. So, it is actually started at the beginning of the Polypetalae under Thalamiflorae. The ranales, even by the modern morphologists also believed that the ranales should be the primitive family and it should be kept at the beginnings of the classification. Knowingly or unknowingly, Bentham and Hooker kept ranales at the beginning of the Thalamiflorae, which is very justifiable at the time of the 19th century. Even the placing of the unisexual monocot families after bisexual families. For example, Palmae and Ericaceae after Liliaceae, that is Palmae coconut family and Ericaceae is also another family which were kept after Liliaceae. So, these unisexual families are kept after bisexual families. The series Glumaceae, which is with extremely reduced flowers and inflorescence, are placed at the end of the flowering plants. This Glumaceae contains the Poaceae family, which is actually placed at the end of the classification, is also justifiable. When you observe the last slide of that is a classification of the Bentham and Hooker, there the flowering plants were divided into Dicotyledonnae, Gymnosperms and Monocotyledons. The place of the Monocotyledons is also justifiable after Dicotyledonnae and Gymnosperms, because even the modern biologists also believe that the Monocotyledons are the most advanced family and they should be at the end of the classification. So, that position of the keeping the Monocotyledons after Dicotyledons and Gymnosperms is also very justifiable, and the system is never conceived by the basis of the phylogeny, already I am telling, but the theory of organic evolution was announced the Darwin and Wallace in somewhat in 1860s. So, any criticism of the system is based on the phylogeny only. So, in the Polypetalae, when you observed the classification, the Thalamiflorae is that is the Polypetalae is divided into 3 series: Thalamiflorae, Disciflorae and Calciflorae. See, in the Dicandols, this system is actually based upon De Gesso and Dicandol, where there was no Disciflorae in their classifications. These two great systematists actually they derived a new series that is called as the Disciflorae and kept in between Thalamiflorae and Calciflorae. Keeping the Disciflorae in between the Thalamiflorae and Calciflorae is also justifiable, because the Thalamiflorae includes hypogynous flowers, Disciflorae includes perigynous flowers, Calciflorae includes epigynous flowers. So, there we observe a marked evolutionary tendency covering from hypogyny to epigyny. So, this Polypetales grouping is considered as a natural group. Next, monocotyledons, that is in the Polypetalae, in the Gamopetalae, you can observe the three series starting from the Inferae, Heteromerae and ending with Bicarpellatae. Placing the Bicarpellatae after Heteromerae is also justifiable, because there is a reduction in the number of the carpels, Bicarpellatae. It is having the flowers with two carpels, whereas Heteromerae it is having more flowers having more number of the carpels. So, more to reduction in number is considered as a evolutionary significance. That is why they keeping the Heteromerae, that is before the Bicarpellatae is also somewhat not somewhat, it is fully justifiable, and there is a marked significance towards actinomorphic flower to zygomorphic flowers, because in the Bicarpellatae there are 4 orders, that is gentianales and personales, where the flowers are actinomorphic and leaves are alternate, and the other two orders are personales and lamiales, where the flowers are zygomorphic and phyllotaxy is opposite. So, moving from gentianales to lamiales, we found from passing the trend to from actinomorphic to zygomorphic condition. So, this is also watched from the significant of the evolutionary tendencies. That is why the placing of the Bicarpellatae after Heteromerae is also justifiable somewhat in the Gamopetalae when compared to the Polypetalae, which is a very natural grouping of the plants. Coming to the Monochlamydeae, it is somewhat unnatural group, and this Monochlamydeae actually based upon the classification on a single character, that is the perianth in a single whorl. Whereas in the case of the Polypetalae and Gamopetalae, there are two types of the conditions. The perianth is in 2 whorls and the perianth is in single whorl. Single whorled perianth flowers are placed in Monochlamydeae, whereas the 2 whorled flowers are placed in Polypetalae and Gamopetalae. In Polypetalae, the inner whorl of the perianth, which is free, that is polypetalous, means poly means free and petalous means petals, the second whorl of the perianth. Gamo, that is the fusion of the petals, is considered somewhat more advanced and given second position. Whereas coming to the Monochlamydeae, which is the third subclass, it is actually done based upon the single character, that is the presence of perianth in a single whorl. And the next, the place of the gymnosperms is also, it is now keeping the gymnosperms in between the dicots and monocots is also not done properly, because these two great systematists actually ignored the important discovery of the Robert Brown, who discovered that the gymnosperms is a separate natural group possessing naked ovules. Naked ovules is a specific character of the gymnosperms. See, the spermatophyta actually divided into 2 divisions, that is gymnosperms and angiosperms, based upon the ovule character. Ovules are naked, that is in gymnosperms, whereas ovules are closed in the angiosperms. So, these angiosperms must be treated as a separate group. Already this was discovered by Robert Brown. These two systematists actually ignored this important discovery done by the Robert Brown and placed in the gymnosperms, that is in between the dicots and monocots. So, keeping the gymnosperms in between the dicots and monocots is totally unjustifiable. And the other, coming to the Monochlamydeae families, that is unisexuals is placed at the end of the Monochlamydeae. So, it is somewhat justifiable, but the Curvembryeae and the Curvembryeae, which is highly related to Caryophyllaceae of the Thalamiflorae of the ranales, actually placed under the Monochlamydeae because of the presence of the single whorl of the perianth. Except for this character, all the remaining characters are lie towards the Thalamiflorae, but ignorantly these two scientists placed under Monochlamydeae, that is Curvembryeae. So, this Curvembryeae would have been placed under Thalamiflorae. That is why the related families are all separated because of the taking the single character, and they give undue importance to the habit of the plants. That is, they have created unnecessarily two series, that is multivovulate aquatica and multivovulate terrestris, depending upon the habit conditions. Plants can live anywhere, because in the same family the plants live in water, in dry climatic condition and in mesophytic condition. We cannot take the habit only as a character for the differentiation of the plants. They have taken the aquatic habit while dividing the multivovulate aquatica and multivovulate terrestris because of the terrestrial habitat. So, that is why they gave undue importance even in creating these two series. The same thing they have followed in the monocotyledons. That is monocotyledons started with microspermae. That is, in the microspermae the Orchidaceae family was there. This Orchidaceae family, having the small ovules along with the Hydrocharytaceae, even though it is not related to Hydrocharytaceae, it has placed under microspermae because of the presence of the microovules, that is microspermae. And the next thing, the important family, that is Epigynae with the Liliaceae having the hypogynous flowers, it has given a third position in the monocotyledons. And Apocarpae, that is the fifth one, Apocarpae, which is having the free carpels, has also given at the end. At the end means before the glumaceae. So, the placing of the Apocarpae should have been at the beginning of the monocotyledons because of the free carpels and other characters, but they have given somewhat last positions. So, this monocotyledonous grouping is also somewhat unjustifiable. And in coming to the Gamopetalae, it is a very important noticeable thing that it has started with inferior ovary flowers, that is inferae, means the order, that is the series possessing the families with the inferior ovary, that is Heteromerae. In fact, Heteromerae and Bicarpellate are having hypogynous flowers. In inferae, which should be at the end of the Gamopetalae, has given undue importance and placed at the beginning of the Gamopetalae, which should have been at the end of the Gamopetalae, because due to this keeping of this inferae at the beginning, the Asteraceae, which is a highly advanced family, it has not given due importance, and it came in the beginning of the classification, that is Gamopetalous grouping. So, this Asteraceae must be placed at the end of the Gamopetalae. So, it must be somewhat inverted, that is Heteromerae, Bicarpellate and inferae is the correct position, but they have grouped the Gamopetalous families taking from epigynous condition to hypogynous condition, which is highly reverse to the Polypetalous groupings. See, the two systematists, even though they explored a lot of work while traveling to the wide variety of places, even they came to India. The Hooker came to India and established the Botanical Survey of India, that is not the Botanical Survey of India, it is the imperial under the British ruling. there was British ruling at that time. So, Presidency of India actually established a survey institution and called the Botanical Survey of India now. So, this Botanical Survey of India actually doing the lot of explorations. Even the Dalton at that time, in 1860s to 70s, he explored Indian flora also. So, it is a risky thing to come to the nook and corners of the world, to go to the nook and corners of the world and bringing the plants and doing the work. It is highly difficult for the taxonomists, but they never care for the health or money or anything. They did rich explorations, and giving the data of nearly 97,000 plants means it is highly appreciable, because they have given at the end of the classification keys. Keys are also very important in the Bentham and Hookers of the classification. Actually, the keys, or even today, they are very helpful for the recent taxonomists also. Even we go to the field also, first we observe the plant whether it is a dicotyledon or monocotyledon. The dicotyledon is we are observing based upon the characters, looking at the leaf first, whether it is a reticulate venation or parallel venation, whether it is a tetramerous flower or pentamerous flower. So, when we look at the monocotyledon, we are observing at the leaf whether it is having parallel venation or trimerous flowers. So, these are the key characters actually given by the Bentham and Hooker for each and every grouping. So, these are most valuable. See, even that is polypetalae, that is polypetalae means you can go when you go into the field, whether the plant is belong to the polypetalae or gamopetalae, just you say that this is polypetalous member or gamopetalous member, looking at the perianth. So, we are just how this knowledge we are acquired means by the actually the knowledge given by the Bentham and Hooker only. That is why all the botanists must be acknowledged to the Bentham and Hooker for providing this great monumental work and great knowledge to the plant taxonomists. Even today, not only for the taxonomists, any botany student, it is also very important to know about the Bentham and Hooker's classification, not only for the academic curriculum, from the botanical aspects also it is highly important to know for everyone to go through the Bentham and Hooker system of the classification. Leaving the demerits, of course demerits will be there when we are doing the work. So, for every experiment there is a 80% or 100% results. So, we must see the merits of the classification, we must look at the keys provided by the Bentham and Hooker. So, in that way we must look at the Bentham and Hookers for the merits only. Otherwise, these demerits we must rectify. This would be the greatest natural type of the classification. Even today we are using it, means it is nothing but it is the highest rate of contribution to the plant world. Students, I would like to discuss the phylogeny of angiosperms. Here you are observing two words, phylogeny and angiosperms. Phylogeny is nothing but discussion of the origin and evolution of the living organisms, and we are discussing only today about the angiosperms only. That is the time of origin when they have evolved, and the geographical location where from actually they came. The angiosperms, the today present angiosperms are actually existing everywhere, that is in mesophytic condition, in water, in dry lands, everywhere. We are observing the angiosperm plants, but the gymnosperms, pteridophytes, bryophytes are restricted to some areas only. These angiosperms, wherever we go, we are finding them. So, what is actually the real reason why they have existing everywhere? What could have the reason to make the angiosperm to exist everywhere, suppressing the remaining the plants of the plantae? And finally, the ancestral plant group from which they have evolved is also very important major issues to know about when we are finding the origin and evolution of the angiosperms. The next is phylogeny. I have explained, that is origin and evolution. And coming to the angiosperms, being the botany students, you all know that angiosperm is nothing but it is a Greek term. That is, angion means enclosed, that is in a vessel like structure, and sperm means a seed. The seeds are enclosed, whereas the other term, the gymnosperm, where the ovules are naked. It is one of the important diverse group of the plantae, covering more than 2,90,000 plants spread over 350 families. And this unique feature of the angiosperms is possessing of the flower. That is, the flower is a highly specialized structure in which there is a arrangement of specialized leaves arranged in a cluster. This flower is especially meant for reproduction only. So, this is the sexual organ of the plant body. So, these angiosperms actually existed at what time is also a debatable question. See, angiosperms are showing a lot of diversity, having herbs, shrubs, plants, climbers everywhere. And even the number is also, in some families it is low number, in some families are having larger numbers. So, the diversity, all the families in the angiosperms are equivalent or not equivalent in diversity. Certain families are showing larger number. For example, Asteraceae, Orchidaceae and Poaceae are having larger number of these species. But all these plants are actually have been around us for a long time. Actually, the plantae, the group of the members of the plant kingdom, possesses amorphous range of the amazing range of the diverse forms of the land plants. Leaving the algae, which are aquatic plants, the land plants includes the bryophytes, that is mosses, and pteridophytes, that is ferns, conifers, gymnosperms and angiosperms. All these plants are around us for a long time. For a long time means when actually they have come to the land. It is also very important to know for the science students. We can't say that for a long time. In a mythological data somewhere, sometime, we can't say like that. We must specify at what time exactly, not the exact date, at least in which era. According to the geological time scale, we must say the plants have evolved at this period. Coming to the origin and evolution of the plants, here you are observing the geological time scale. I have started with the Ordovician period, when the plants actually first appeared. Even though they have appeared in the Ordovician period, they did not resemble with the modern plants until late Silurian period. By the end of the Devonian period, about 360 million years ago, there was a lot of structural and shape differences by which we can define the modern plants. Actually, the end of the Devonian period only we got the different types of the plants, including tiny herbs and the tallest plants of the forest. But the exact period of the angiosperm origin is still remained a mystery. Why? Because why this mystery? Even 100 years back, the father of evolution, that is the great scientist Charles Darwin himself described this origin and evolution of the angiosperms as a abominable mystery. Why? He called abominable mystery. Even this mystery remained for a long time, even for today also it is mysterious, because he referred this term because of the lack of the early fossil record of the angiosperms. The fossil angiosperms are available today, but they are troublesome. We could not interpret depending upon the fossil study, because they are showing mix of the characters. Mix of the characters are actually seen which would define the modern group of the plants, not the exact data of the angiosperms, because the lack of the early fossils attributed to the thought that they might have lived in the montane habits or dry upland areas which are not optimal for fossilization. So, what are the optimal conditions for fossilization? See, whenever for the fossilization there must be a hard structure in the plant body. So, when it has fallen, for the fossilization there must be some soft rock, so that the hard material of the living organism can be impressed into the soft material. So, these are not the conditions. That too, fossilization occurs in the moist conditions only. That is why the fossil scientists, the paleontologists, thought that the primitive angiosperms, they have lived in the montane habitats and dry upland areas. And actually they came suddenly without no obvious ancestors, lacking the record of 80 to 90 million years prior to the appearance. So, lacking the record of 80 to 90 million years in the history of the paleontology is a big drawback. That is why we cannot envisage who is the ancestor of the for the angiosperms. Even the regular data of the, that is diversity and rapid diversification in an exponential increase occurred in the Albian and mid-Cretaceous period. Even though they appeared in the mid-Cretaceous period, the actual ecological role of the angiosperms carried out in Cenozoic era. That is, in the Cenozoic era means it is after Cretaceous period. So, even though they have evolved at the end of the Cretaceous period, in the Cretaceous period the gymnosperms were abundant and they are existing in a diverse forms. So, they actually Taxon felt that these might have originated from the gymnosperms only. So, regarding the time and origin and probable ancestors, there are different opinions about the facts about the time and origin of the probable ancestors. The key innovations were explored, but there is no conclusion, that is a concurrent opinion about the origin of the angiosperms. Some consider that the seed plants of the Carboniferous and Permian periods 200 to 250 million years as the possible ancestors. The other group feel that these the origin may be in the Jurassic period, that is 150 million years ago, to be the probable ancestors. Some regard them as a Cretaceous period, that is 100 million years ago. At one time or the other time they have felt that not later than the that is a Cretaceous period, all the angiosperms have evolved from the group of the plants Lycopodiales, Filicales, Cycadales, Pteridospermales, Benitoides and Nettles. These groupings are the probable ancestors of the angiosperms. Next, the important factor, what could make the angiosperms to be differentiated from the gymnosperms? All the paleontologists considered that the two important factors which can be differentiated from the gymnosperms are two. That is, one is the flower, already we discussed. In gymnosperms the flower is lacking. That is, of course, there is a microsporophylls and megasporophylls which are arranged in the form of a cones. And the other important aspect of the pollination, that is important type of the pollination, that is insect pollination. Whereas in gymnosperms there is wind pollination. In angiosperms insect pollination. The flower itself is a very attractive organ of the plant. So, whoever, even the children or youngsters or older people, whoever may be, likes the which part means it is either flower or fruit. So, the flower even liked by the insects also. So, this insect pollination favored the angiosperms to disseminate all over the habitats of the world. So, the next what are the other characters made the plant to become an angiosperms. So, the vessels are also very important in the secondary xylem. Leaves are also of course very important, and flowers already we discussed, they are very important, and the pollen wall is also structure, that is pollen apertures are also differentiated from the other grouping of the gymnosperms and other pteridophytes, and reduced female gametophytes. Ovules are enclosed in a carpels, double fertilization. All these special characters made the plant to be a special group of organism, that is angiosperm. So, the next very important point to be dealt with is whether the angiosperms are monophyletic or polyphyletic. Monophyletic taxon. So, what is a monophyletic taxon means? A group of the descendants coming from a common ancestor, that is there is a single ancestor giving rise to the all the descendants, different type of the descendants. The theory was, this view is supported by Hickey and Doyle and proposed by the several taxonomists like Taxon and great taxonomists like Taxon and Cronquist. But Dahlgren also believed that the probable ancestor is Gymnospermous members. The view is why we can say that the angiosperms are monophyletic. How can we say that these angiosperms are monophyletic? Because there is a remarkable consistency. The view can be watched by the remarkable existence of the sieve tubes throughout the plant, throughout the angiosperms, that is endothelial layer of the anther wall and staminal tubes and fertilization and triploid endosperm. All these characters are consistent throughout the angiosperms. That is why some of the group of the taxonomists felt that these are monophyletic in origin, and the other group felt that the grouping of the angiosperm is polyphyletic, that is the grouping does not have a common ancestors. This view is actually argued by the Cronquist, Hughes, Gaines, Mewes, and several people argued that the dicots and monocots originated at different times at different locations, but angiosperms as a group, they originated as a polyphyletic manner. But based upon the fossil study, the paleontologists believe that the angiosperms as a group originated in a monophyletic manner, but the families or the group of the families originated in a polyphyletic manner. So, as a group, angiosperms, it is a monophyletic origin. As a group, the families are polyphyletic in origin. But there are various theories regarding the explaining the origin and evolution of the angiosperms. That is one is the Benititalian theory, and the isoetus monocotyledon theory, coniferals and theory, Natal's theory. There are several theories, but today we are restricting to only two theories, that is Benititalian theory and pentoxylales theory, because of the time schedule. So, coming to the Anthostrobilus or Benititalian theory, Benititales is a very important fossil group that is appeared in Triassic and became extinct towards the end of the Cretaceous. That is, this theory proposed by the Saporta and Marion, followed by the Parkin and Arbor. That is, Benititales actually having three genera, that is Williamsonia and Williamsoniella and Cycadioidea. Here you are look at the flower of the Cycadioidea. That is the strobili of Cycadioidea is resembling with the flower of the Magnolia, that is which is the member of the Ranales in the Bentham and Hookers of the classification. So, Magnolia is a very primitive member, that is very primitive genus of the Magnoliaceae, representing Ranales grouping, and this Cycadioidea and Magnolia are actually showing similarities in some characters in their flower structure. So, both of them are bisexual. In both the plants, it is that is the thalamus is erect, conical and elongated, in which the bracts, sporophylls, that is microsporophylls or megasporophylls, are arranged from bottom to apex. But there are several differences in the structure, in the morphology. Here in Magnolia, the stamens are free and they are arranged spirally. In Cycadidea, they are connate and they are arranged in a whorl manner. In the Magnolia, there are no sterile scales. Sterile scales means what? This in Cycadidea, in the megasporophyll, there are sterile hairs in between the megasporophylls, which are called as the interseminal scales for protection. So, there are no such structures in Magnolia. Even the pollen grains are also shedded in the stigma, that is the real character of the angiosperms, but there are no such structures. They are directly shedded over on the ovules. So, there are no staminal tubes, actually true to speak, in the Cycadidea. Even the endosperm is also copious in the case of the Magnolia. The seeds are non-endospermic in Cycadidea. So, there are similarities in the structures and there are also differences in the structures. How can we assume the similarities and differences from the that is evolutionary point of view? So, similarities, some that is Parker and Arbor and Parkin stated that the similarities are due to the they have originated from a single ancestor. That is why they are showing the same similarities. But how the differences have come? Because they have taken, that is divergence from the same line and they have evolved as a different groupings, that is a parallel evolution or divergent evolution. That is why they are showing the dissimilar, that is the differences. So, the people considered that we cannot say that definitely the angiosperm grouping have derived from the Benititalian group because of the differences in the structures of the Cycadidea and Magnolia. The next other important theory is pentoxylales theory. So, pentoxylane is also other group of the fossils under pteridospermales. We use proposed that these angiosperm have originated from the pentoxylales. They first appeared in Paleozoic and diversity and abundance observed in the Jurassic, continuing into the early Cretaceous. So, this pentoxylon, the genus pentoxylon of the pentoxylales can be compared with the pandanus of the monocot. But similarly, as we looked at the Benititales, Benititales grouping is showing similarities and also differences. Same, the pandanus is also showing similarities and differences. So, the pandanus is a monocotyledonous plant showing the somewhat common features with the pandanus, that is pentoxylon is showing common features, and Meius enlisted certain characters similar to the pandanus and pentoxylon. Plants are erect and sub-erect and dioecious, stems are slender and cylindrical and pentoxylon, and stem bears a terminal tufts of the strap shaped leaves arranged spirally. Even the inflorescence arised either laterally or in the axils of the leaves. In both the cases, the inflorescence are observed in the same manner. Even the peduncle have tracheids and with spiral thickenings and bordered pittings. So, this is also the common character, but the seeds are enclosed in the sarcotesta, that is also a common character belong to the both, and a fleshy layer, that is the seed coat consisting of the two layers, is also comparable to the genus. So, all the features what we have seen are common to the both genus. That is why we can't say that even though they are showing the same features, that is common characteristics or common features, we can't assume that pentoxylon is only the ancestor to the angiosperms. That is why even Pant and Kidwai, they stated that, and they argued that even the pentoxylon cannot be also considered as the probable ancestor of the angiosperms. There are other several theories like isoetus and monocotyledon theory, Nettles and dicotyledonous theory, and coniferales theory, coniferales and Amentiferae theory. So, these are some other theories which could explain the characters which are related to the angiosperms and gymnosperms, but in the next class we can watch over them. Students, today I would like to tell about the dicot and monocot embryo development along with the structures. The embryo development and structure, how and why it is necessary for the botany students to know, because the taxonomy in some aspects, in some areas, the important aspects of the embryology is also essential to know for the student or for the teacher or for the scientist. You know very well that the embryo is a resultant product of the fertilization. So, based upon the that is structures are also we could able to differentiate which is a dicot and what is a monocot. See, in the dicot there are two cotyledons, and in the monocot there is a single cotyledon. Even the position of the plumule, that is the shoot tip, it occurs distally in the case of dicot embryo and it occurs laterally in the case of the monocot embryo. Even the position of the cotyledons also in the dicots you can observe laterally. In the case of the cucurbita or tamarindus, you are observing the cotyledons are emerging laterally. Whereas in the case of the monocot embryo, that is in the case of the cereals, you can directly watch it. That is a the cotyledon arising laterally from the radicle, and the structures like coleoptile and coleorhiza are absent in the angiosperms, whereas they are present in the monocots. Even the suspensor is also very large in the dicot and small in the monocots. So, that is why by these key features we are able to differentiate between dicot and monocot embryos when you observe under the microscope. That is why even the embryological characters are also very important while describing or differentiating the plants. Development of the coming to the development of the dicot embryo, here is a beautiful slide describing all the events of the development of the dicot embryo. In the A, you are observing a small cell, that is the zygote. In a typical dicot development, dicot embryo development, the zygote becomes enlarged and divides transversely to form two cells, two unequal cells, the two by transverse division. The larger cell is called as the basal cell, which is called as the suspensor, and the other cell lying towards the antipodal end is called as the terminal cell or embryo cell. That is, the suspensor cell undergoes few more divisions to form a filamentous suspensor. Here you are watching above an elongated structure, that is top to bottom. The lower, in the middle 4 cells are there, above 3 to 4 cells are there. The 3 to 4 cells are related to the suspensor. So, the part of the upper part of the apical part of the suspensor is somewhat swollen, that is called as the hastoria. This hastoria shows inward growth, and this suspensor is able to push us, and it helps in pushing the embryo towards the endosperm. And the hastoria sometimes having the inwards growths are also helps in absorbing the food materials. So, leaving the suspensor cell, that is Hastoria and other things, the embryo part divides transversely vertically at right angles to the each other first time, forming the 4 cells, that is called as the quadrant stage, and later then transversely to form the 8 cells, that is called as the octant stage. In the octant stage, the cells are arranged in 2 tiers, 4 cells of each, that is epibasal and hypobasal. That is epibasal and hypobasal. Epibasal means it is lying towards the lower cell and it is terminal in position. Hypobasal means it is towards the suspensor side. This epibasal gives the plumule, that is radical and root tip, whereas the hypobasal gives the hypocotyle part of the dicot embryo. So, next if you observe in the slide, that is suspensor cell, that is lying towards the embryo side, this hypophysis, that is the end of the suspensor cell which is towards the embryo side, is called as the hypophysis. That hypophysis forms the radical or root tip part. So, hypophysis forms the radical and root tip part. Epibasal is forming the epibasal cell is forming the plumule and hypobasal cell is forming the hypocotyle. So, along in the epibasal are also able to form the cotyledons along with the plumule. So, this next after octant stage, the 8 cells are divided periclinally to form the dermatozen or protoderm. Protoderm. This protoderm differentiated into epidermis. Later, the inner walls of the embryo is also differentiated into pleuron and the cortex, general cortex, that is ground meristem. This ground meristem develops into the cortex and the procambium differentiated into the vascular tissues. When you observe in the beginning, the embryo is spherical or globular in the shape. When it attains the radial symmetry, it forms the proembryo. This proembryo, when differentiated into radical, plumule and cotyledons, then it is called as the embryo. These cotyledons, they grow from the side, having the plumule at the center. These cotyledons are very fast in growth and attains the shape. So, then it becomes a heart shaped in structure. It is there in the slide also, and there is a structure which is showing which is called as the cotyledons. So, a typical dicot embryo consists of the embryonal axis and 2 cotyledons. The part of the embryonal axis above the cotyledons is called epicotyle, that is it terminates with the stem tip, and the part of the embryonal axis below the cotyledons is called hypocotyle. It terminates with the root tip called radical. The root tip is covered with the root cap. Next, coming to the development of the monocot embryo, it is similar initially, that is a division transversely forming the 2 cells, that is the basal cell called as the suspensor and the lower cell called as the embryo cell. The larger cell becomes enlarged and it becomes vesicular, forming the suspensor, and the embryo cell divides transversely forming 2 cells, that is the terminal cell which undergoes again series of divisions forming the hypocotyle and other structures, whereas the middle cell is also undergoing series of divisions forming the epicotyle structures and also adding some cells towards the suspensor. That is why in the development of the monocot embryo, we do not observe structure like hypophysis. So, hypophysis is there in the dicot embryo, whereas it is absent in the monocot embryo. This monocot embryo have only one cotyledon and is called scutellum. It is situated towards the later side of the embryonal axis. Actually, it has moved towards the lateral side. The axis at its lower side, that is lower side of the embryonal axis is called radicle, and its root cap it is enclosed in a sheath called coleorhizae, and the part of the axis above the embryonal axis is called epicotyle and enclosed in a foliar structure coleoptile, and the epiblast is another structure which is showing the rudiments of the second cotyledon. Altogether, Johansen recognized 6 types of the embryo developments among angiosperms. This is the piperoid type, where the zygote is divided by the vertical division, and monagrad and asteroid types, where the zygote is divided by the transverse cell, that is a transverse wall, in which again if the basal part cell takes place full or no part, then it is considered as the monagrad type. If both basal cell and terminal cells take part in the development of the embryo, it is called as the asteroid type. The other 3 types are caryophyllaceae and solenoid and chenopodioid types, where the terminal cell is divided by the transverse wall. So, if the basal part plays a little role, then it is called as the caryophyllaceae, where the suspensor is very large, and the basal part takes place somewhat, then it is called solenoid type. If the basal part and terminal part takes place, then it is called as the chenopodioid types.
Vera Vera Muripala क्या गई अगुन फूल हो
పోటీ పరీక్షల్లో అన్ని సబ్జెక్టులతో పాటు అనివార్యంగా మనకి ఆంగ్ల భాష కూడా ఉంది. మరి చాలామంది విద్యార్థులు ఆంగ్లం అనగానే ఇదేదో చాలా కష్టమైనటువంటి సబ్జెక్ట్ అని భయపడుతుంటారు. ముఖ్యంగా గ్రామీణ విద్యార్థులు చాలా బెంబేలు ఎత్తిపోతుంటారు. వాస్తవానికి అలాంటి భయం అక్కర్లే. మంచి ప్రణాళిక, సమయపాలన, తర్వాత పదే పదే తీసుకున్నటువంటి అంశాన్ని బాగా అవగతం చేసుకోవటం, ఇలాంటివి మనల్ని విజయ తీరాలకి తీసుకెళ్తాయి. అయితే గ్రూప్ 2 లాంటి పరీక్షలో ఆంగ్ల భాషను బేసిక్ ఇంగ్లీష్గా వర్ణిస్తున్నారు. ఇది 10వ తరగతి స్టాండర్డ్లో ఉంటుంది అని చెప్పారు. మరి అందులో ఎలాంటి ప్రశ్నలు వస్తాయి అంటే 10th క్లాస్ స్టాండర్డ్ దాకా అన్ని అంశాలు రావచ్చు. నిజానికి ఒక భాషలో రాణించాలంటే అన్ని అంశాలు, భాషా భాగాల నుంచి పార్ట్స్ ఆఫ్ స్పీచ్ లేదా వర్డ్ క్లాసెస్ అంటాం, వాటి నుంచి మొదలుకొని అన్ని అంశాలను, అన్ని వ్యాకరణ అంశాలను మనం కవర్ చేయాలి. కాబట్టి కేవలం పరీక్షలను దృష్టిలో పెట్టుకొని గబగబా ఏవో కొన్ని ఆబ్జెక్టివ్ టైప్ క్వశ్చన్స్ చదివేద్దాం అనే కంటే లోతైన అధ్యయనం ఎవరైతే చేస్తారో వాళ్ళకి తప్పనిసరిగా విజయం దగ్గరగా ఉంటుంది. ముఖ్యంగా ఇంగ్లీష్లో లేదా ఏ సబ్జెక్టులోనైనా ఒక్క మార్కు చాలు, అది మనల్ని ఉన్న స్థితి నుంచి ఉన్నత స్థితికి తీసుకెళ్ళవచ్చు, లేదా అమాంతం మనకు ఆ ఉద్యోగం రాకుండా కూడా చేయవచ్చు. కాబట్టి ముందుగా ఒక చక్కని మైండ్ సెట్ పెట్టుకోవాలి. ముఖ్యంగా గ్రామీణ విద్యార్థులు ఇంగ్లీష్ అంటే అది భయపడాల్సినటువంటి అంశం ఏం లేదు. ఒక ఆటలో ఒక ఆటగాడు ఓడిపోతుంటే తప్పు ఆటది ఉండదు, ఆ ఆటగాడిది ఉంటుంది.